Viewers, learn math step by step today and every day. It is series of 10 problems which you will be working out daily on daily basis. This is about a chapter triangle and this is episode 1. That is for every 10 problems I will be having different episodes. This is meant for 10th standard CBSE exam last minute preparation series. Are you scared of board exams? Don't worry. Work out 10 problems with me daily and every day, and you can win over your board exam. Working out text, NCERT textbook, CBSE board textbook. So, in this, in chapter triangle, exercise 6.1, today we are doing 10 problems. So the first problem is about fill in the blanks with using the correct words given in the bracket. Here the main important thing what you can notice is about similarity and congruency. What do you understand by similarity? See, whenever we are comparing two shapes, we have two important things. One is size of the object and shape of the object. If both size and shape or almost same, then we can think that the objects are similar. They look the same. Say, for example, I'll take a triangle and draw one more triangle. The size may be different, but both the things have three sides in both the triangle. And both and all the three angles of one triangle may be the same of the other triangle. So here what matters is the size is the difference and the shape is also the same. Then we call it as similar objects or similar shapes. So what is congruency? Congruency is it is the duplicate of the same object. Say suppose I take a circle of 5 centimeter radius. If I draw one more circle of 5 centimeter radius, then both the circles are congruent. Say suppose I'll take an equilateral triangle and take one more equilateral triangle of the same sides and same angles. Of course, equilateral triangle will all the angles will be the same. So if I draw both the triangles, both have the same shape and same size and also the angles are same. So it is congruent. So based on this, let us fill in these blanks. So the first question is all circles are whether it is congruent or similar. All circles are similar. That is because you know that when I draw circles, they may be of different diameter or radius. So when I say just circles, I'm not mentioning about the radius of each circle. That means it is similar. All squares are similar. Yes, it is similar. I can draw a small square as well as a big square. So it is not congruent. Then all equilateral triangles are similar. Is it isosceles triangle which is similar or equilateral triangle? That is the question. Isosceles means what? Angles will change and sides will change even though the shape looks the same. So it is of different size. Whereas equilateral triangles, if two equilateral triangles are there, then they are equal to one another. That is, they are similar. But here the length of the sides may be different. Okay, that is the first question. First three, fill in the blank. The next one, two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. That is, equal or proportional is the given choice, and we should choose proportional. So hope I think you have understood the concept of similarity and congruency from this first question. Having understood the concept of similarity and congruency, now in the second question, they are asking for examples of similar figures and non-similar figures. It is very easy. You can choose anything like any two circles or any two squares, as we discussed previously, they are similar figures. And then in the second question, non-similar figures, we can give the example of equilateral triangle and a scalene triangle whose no two sides are equal. An equilateral triangle and a right angle triangle can also be given as an example. This question they have asked about these two figures which they have given with all the dimensions, and they are asking you whether they are similar or not. Now that we have understood what is similarity, it is very easy to answer this question. It is no, because the corresponding angles are not equal. See, none of the angles are matching with the second shape or second, this is the square and rhombus. Rhombus is different from square, as you know very well. So, no, because corresponding angles are not equal. The first figure is rhombus and the second is square. This question, where they have given two triangles, all the dimensions are given except EC is to be found out in the first diagram, and in the second diagram we have to find out AD in the second one. It is very simple. Here we have to use basic proportionality theorem. As per basic proportionality theorem, you know that the sides should be proportional to each other. Based on that, in triangle ABC, DE is parallel to BC, which is already given. Therefore, AD by DB is equal to AE by BC. So now it is 1.5 by 3 is equal to 1 by EC. Therefore, EC on cross multiplication will be getting, and on simplification it will be 2 centimeters. So similarly, in triangle ABC, DE is parallel to BC, which is given. So using basic proportionality theorem, AD by DE is equal to AE by EC. Therefore, AD by 7.2 is equal to 1.8 by 3.4. So on further simplification and cross multiplying, we will get AD is equal to, this is on cross multiplication, and further simplification, we will get AD is equal to 2.4 centimeter. Let us understand this question. E and F are the points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. As you can rightly see, all the dimensions are given, and we are supposed to find out whether EF is parallel to QR. In the second case also, the dimensions are given, and we have to find out whether EF is parallel to QR. And in the third sub question also, the same thing, all the dimensions are given, and we are supposed to find out whether EF is parallel to QR. This is how we can understand the problem. So how to work it out? This is based on basic proportionality theorem. So P by EQ is equal to 3.9 by 2. That is this by this. And then it will be 1.3 by 1. So PF by PR also we are finding out. So this is 1 and this is 2. And then whether both the things are proportional to each other. No, it is not. The ratios are different. Therefore, EF is not parallel to QR. So similarly, in the second case, PE by QU is equal to 4 by 4.5, which ultimately on simplification will be 8 by 9. So from 1 and 2, PF by RF also if we do, it will be 8 by 9. So 1 and 2, we will get PE by QE is equal to PF by RF. So here what happens, EF is parallel to QR by converse of BPT. So similarly, in the third stage also, we are finding out the ratio of the sides, and finally, we are finding out that the by basic proportionality theorem that EF is parallel to QR. So this question is a repeated question. It has come in 2013 as well as in 2016. So let us work it out in detail. So here we have two sides, AB and AD. These are the two sides which are important. As we know, AM by MB is equal to AL by LC. AL by LC. So this is because of basic proportionality theorem, and we will call it as 1. So in the triangle ACD, ACD, the same thing, similar to the upper triangle, it will be AN by ND is equal to AL by LC. This is also by basic proportionality theorem. We will call it as 2. So from 1 and 2, this is the first one, and this is the second one. Taking reciprocals, what happens? MB by AM plus 1 is equal to ND by AN. This is how we take reciprocal, by adding 1 on both the sides. Then we will simplify. Then it will become MB plus AM by AM, ND plus AM by AN. So when you add these two, it will be AB by AM, which is equal to AD by AN, or AM by AB is equal to AN by AD. So now taking proportional reciprocals, we get whatever we have to prove, that is AM by AB is equal to AN by AD. So hence we have proved this problem. This is also one of the problems based on basic proportionality theorem. So here also what we have to do, we have to take this triangle ABE, and we can get the ratio as AD by DB is equal to EF by BF by basic proportionality theorem. We will call it as 1. And then ABC is the triangle which has to be considered, because DE is parallel to AC, DE is parallel to AC. So therefore, AD by DB is equal to EC by PE. Once again, by basic proportionality theorem, we will call it as 2. So from 1 and 2, what is happening? We get that FE by BF is equal to EC by E. Therefore, because LHS on 1 and 2 are the same, therefore BF by FE is equal to BE by EC by taking reciprocal, and we have proved this problem. So here in this triangle PQR, in this triangle PQR, D is parallel to OQ, which is given, and therefore PD by DO is equal to PE by EQ. We will call it as 1, and it is based on basic proportionality theorem. Similarly, we will take triangle PQR, and then PRO. So DF is parallel to OR, therefore CD by GH is equal to AC by FG, which is 2 by basic proportionality theorem. From 1 and 2, we will get this ratio PE by EQ is equal to PF by FR, because LHS of 1 and 2 are the same. Therefore, EF is parallel to QR by the converse of basic proportionality theorem. In all these proof problems, all that we have to do is first locate the triangles where the sides are in proportion. So in this question, as per the given data, in triangle OPQ, AB is parallel to PQ, which is given. Therefore, AO by AP, therefore AO by AP is equal to OB by BQ. We will call it as 1 by basic proportionality theorem. Similarly, OPR, 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 this triangle, we have AC is parallel to PR, therefore OA by AP is equal to OC by CR by basic proportionality theorem. We will call it as 2. So from 1 and 2, OB by BQ is equal to OC by CR, and LHS of 1 and 2 are the same. Therefore, BC is parallel to QR by converse of basic proportionality theorem. So this will be the last problem for the day, and here is our question. Using theorem 6.1 from the textbook, prove that a line drawn through the midpoint of one side of the triangle is parallel to the another side bisects the third side. This has appeared in the board exam of 2012 and 2014. Please make a note of that. So what is the solution? We are given with the triangle ABC. So in which D is the midpoint of AB and DE is parallel to BC. DE is parallel to BC. So this is the data which is given. So proof. In this triangle ABC, DE is parallel to BC, which is already given. Therefore, we are taking proportion AD by DE, AD by DB, AD by DB is equal to AB by BC. We will call it as 1 by basic proportionality theorem. So D is the midpoint of AB, which is already given. Therefore, AB is equal to DB. Therefore, AD by DB is equal to 1. So from 1, AE by EC is also equal to 1. So on cross multiplication, AE is equal to EC and E is the midpoint of AC. So this is the 10 questions of today which we have solved in episode 1 and we will continue it by tomorrow with another 10 questions. Continuation will be after this problem. The next problem number 8 of exercise 6.2. Please see that you keep continuing and it will be a very good practice for you in the nth moment. Write your comments for clarification of your doubts, which will be promptly answered. Okay, please like, subscribe, and press the bell icon as an encouragement to continue my work. So every day working out 10 problems with me will be definitely helpful for you. Contact for doubts and online classes on gamma for merchandising at gmail.com. And link for the notes. Shortly, I'll be uploading it and I'll put the link here so that you can directly get your notes and view my other videos also. The link will be provided.